Lesson 6.5, Applying Systems of Linear Equations. Our essential question is, how do you determine which method to use to solve a system? And the three methods that we've worked with are graphing, elimination, and substitution. This first slide is a click and drag. It says, choose the best method to solve each of the systems. So what I want you to focus on this slide is we've got 10 systems of equations over on the left. They're color-coded. And I want you to focus on the form that the equations are written in and which of the methods would be best based on the way that the system is written. So for example, this one that is red, I'm going to put under graphing because when both of your equations are written in slope-intercept form, that's when it makes sense to graph your system. So here's another one where both equations are written in slope-intercept form, and here's a third one. Now I'm going to move over to substitution. When we were working with substitution, what we looked for was one variable that was all alone on one side of an equation. So one variable all alone. Not two variables, not like the graphing examples. We could do substitution on those, but those are both slope-intercept, so we'll say graphing for those three. So substitution would be like this blue one, where there's one variable all alone. X equals 3y minus 1. So you can replace the other x with 3y minus 1. Here's another one that has one variable by itself. And here's a third one with one variable by itself. Y equals, x equals. So graphing, we're looking for both of them to be in slope-intercept form. Substitution, we want one of them to have one variable, whether it's x or y, it doesn't matter, one variable by itself. And then elimination, that's when they're lined up. When they're lined up, the x's, the y's, the equal sign. I could say that they're in standard form, but they're not always in standard form because if that leading coefficient, the leading coefficient right here and right here is a negative, it's not written in standard form technically, but the x's are lined up, the y's are lined up, the equal signs, and then the numbers without the variable. They're all lined up nicely for elimination. So in this section, it's going to be your choice. You're able to choose the best method to solve the system and then use that method. So this first one, you see my choice is graphing. So they're both in slope-intercept form. The red line starts at the y-intercept of 4, so positive 4 on the y-axis, and then it goes down 3 over 1, like this. And then I can draw my line. My blue line starts at the y-intercept negative 4. So down here, and its slope is also down 3 over 1. Draw my line. The solution to this system, well, these lines are parallel. They have the same slope, so they're parallel, which means there's no solution. If your lines do not intersect, they have no solution. Okay, my next system, this system is all lined up. So I could go back to this one actually and explain that I chose graphing because it did say to choose a method and solve, so my method was graphing. Okay, so now on this, I'm going to use elimination because they're all lined up. I don't have an x by itself or a y by itself. They're not in slope-intercept form. They're lined up, and the x's are opposites right away, so they cancel out. If I add the rest of the system, I get negative 2y equals 2. And then I divide by negative 2 on each side, so y equals negative 1. Then I plug in that negative 1 for one of the y's in my original equations. So 4x minus 5 times negative 1 equals 5. -5 times -1 is +5. Subtract 5 on each side. So 4x equals 0, and divide by 4, x equals 0. So these are intersecting lines. There's one solution, and that solution is 0, -1. My next system, I am going to go with substitution on this one because I have one variable all alone, and that is the x. So I circle the x that's all alone, I circle the other x, and what I can replace x with is y minus 9. So y minus 9 plus y equals 15. Combining my like terms gives me 2y, so 2y minus 9 equals 15. 15 plus 9 is 24. And 24 divided by 2 is 12. So y equals 12. Then I take that back to my original right here. X equals y minus 9. So that would be 12 minus 9, which is 3. So x is 3 and y is 12. Okay, our last example. Julie has $175 to shop for jeans and sweaters. Each pair of jeans costs $25, each sweater costs $20, and she buys 8 items. How many of each did she get? So I'm going to use J for jeans and S for sweaters. I need one equation to focus on how many of each she buys. So if she buys 8, and we don't know how many of each she's getting, I need to just simply say jeans plus sweaters has to add up to 8 items. Then on my second equation, I put all of the money in here. So jeans are $25 each, sweaters are $20 each, and she has $175 to spend. Okay. Now, I'm going to use elimination on this system because my equations are lined up. And it says how many of each, so I need to find both of mine. So I'm going to multiply by -20 because that will cancel out my sweaters. So -20J minus 20S equals -160. I have opposites now, so I can cancel out the variable s and finish solving. 5J equals 15. If I divide by 5, J equals 3. So, 3 pair of jeans. I can take this back up to the top. 3 plus S has to equal 8. On a problem like this, you should expect to get a nice number because you're not going to be able to buy you're not planning on buying a half a pair of jeans or half a sweater. So plan on getting good numbers. If you don't get good numbers, you've made a mistake and you need to go back to check your work. So, how many of each did she get? She bought 3 pair of jeans and 5 sweaters. You can reread the problem to make sure that it makes sense. She got 8 items. 3 plus 5 is 8. That's perfect. Jeans are $25 each. 3 times 25 is 75. Sweaters are $20 each. 20 times 5 is 100, so $175. Perfect. Okay, you should be able to write your summary now. Please make sure that you write 3 different sentences in this summary. So you should use graphing if, substitution if, elimination if. Explain each one of them, how you decide when you would use each one of those as your method to solve a system.